Did you not try the test again at home?
Yeah, I tried, but I still don't know where is my wrong. Maybe several questions I understand use wrong ways to start the question.
Did you try the test again?
Yeah.
You tried it again? And what did you get second time?
Some units wrong.
Ah, okay.
And some, you know a class.
Yeah.
Just 50
Yeah.
50%
Efficient.
efficient.
Yeah.
I get the final answer is 15,000.
Yeah.
But the real answer
Yeah.
is 375.
Oh, that's quite different.
3,750. I mean, just the person I get wrong.
Well, this week in the tutorial, we can do the questions that you don't understand. Many questions.
No, it's not many.
Okay, that's good. How many do you think?
3 or 4.
Okay, what do you think?
Maybe 2 or 3. Some question after I look again, I think that shouldn't be wrong. During the exam is so nervous and the time limit time.
Mm-hmm. Yep, I understand. Are you the same?
Yeah, actually, the question about wave.
Yeah.
Yeah. I can't understand why my answer is wrong.
Okay, we can do that in the tutorial. Alright, we'll continue now with the new chapter today called Materials. And the first lesson we're looking in materials is called Density. So if you want to write this down, density. You got your notebook? Oh, summer!
But I can't.
You got yours. Yes, paper, yes. I understand students. How was your chemistry test? Oh, it's tomorrow. And maths test? How was it?
It's not
Maybe
too difficult, only 10 questions.
Yeah.
Actually,
Easy.
the question, our questions is the word.
no, just the
Language.
question. I don't know what's the question, but I write a lot of situation. Situation.
Too many kind of
English.
yeah.
English is your problem, guys. Okay. Density now, you got that?
Yeah.
So, I think this is a word we mentioned, but we only mentioned it once. So maybe you don't remember. So I don't expect you to remember. But I wonder if anyone remembers this word, its meaning.
Row?
Yeah, it's row. Yeah. So that's the formula we'll have a look at. So we've seen this formula. Do you remember the formula, Gail? What is it for row? Row equals, yeah.
M
Yeah.
over V.
Yeah. So you saw it in semester 1 earlier in the semester. It's M over V. And do you remember the units?
MS.
No, MS.
No.
So it's kg.
Yeah.
With S.
kg per. Yes.
Meters.
Yes. Cubed. Thank you, Ben. So and the dimension is mass per length cubed with units of kilograms per meter cubed. And don't say it again, Gal. Let's just see if the other two remember. Summer or Ben. What's the name of this Greek letter? Rho. Okay, good. I don't think it's a bad idea if you write this down again.
Okay.
Especially this word, density.
We have this word in the morning here.
Did you really?
Yeah. But it's not exactly, it's for the sports, for health. another
What was the meaning in sport?
yeah, because we did a lecture of lesson about
Ground?
Bomb.
Oh, Bowen density. Yeah.
About sport.
Yeah, about sports and Bowen density, yeah.
But I remember the definition give us the role.
Yes. But did you remember the word density?
yeah, because we have the word family of this and
Ah.
all the definition of this.
Okay. Okay, got that?
Yeah.
What was the EAP? It was a listening, was it?
A small listening test.
A small listening test about sports. Okay. Right, so, what exactly does it tell us? So, since you had the EAP listening, do you want to try and explain in simple English what is density? What does it mean?
It's about the water and
Yeah.
and how to say the like
Ice,
Liquid.
liquid, yeah.
liquid,
Solid,
liquid,
ice.
like liquid
This
and
one we
gas.
learned more.
Yeah.
Yeah, okay, good. So, but like simply, what is density? Simply, what is it?
The weight of the
Kind of like the weight, but it's more like how much you have
One.
yeah.
in a space,
Yeah.
like the amount in a space. So obviously, some materials have high density, and some have low density. What are examples of materials with high density?
Silver.
Say again.
Silver.
Silver, good. Yeah. What else?
Diamond.
Diamond. Yeah, I think so. Yeah. What else?
Gold.
Gold and silver are quite high densities. So gold, for example, does anyone know its density? How much it is? It's quite large. It's 19,320 kilograms per meter cubed. So this means per meter cubed of gold, there is 19,320 kilograms of gold in a meter cubed. Okay. What I want you to do for me now is I want you to tell me what the density is in grams per centimeter cubed. So this is kilograms per meter cubed. I want you to convert this into grams per centimeter cubed. Let's see if you can get this. Do you need a calculator? No guessing.
It's gram and centimeter.
Yeah. Huh? That's so hard. Forgot your book and your calculator. And you also forgot to wear trousers. It's my joke. It's a good joke, I think. Got an answer? No.
It's the same.
Not night. No. Ben, do you have an answer?
I
Yeah.
19.
Yeah. 19.32 grams per centimeter cubed. Okay, Ben got it. You two look confused. Do you remember how to do this?
What's the meaning of
The question.
yeah.
Okay, I'll do it. No, English.
So, the 10 power of 6
Sulfur is the cm.
Hang on, I'll do it. Look.
It's the cm.
CM, yeah.
Oh, alright.
Yeah? 19.32. Did you get this?
Yeah.
This is equal to 19.32 grams per centimeter cubed. Is that okay? Is that okay?
Yeah, okay.
Are you sure?
Yeah, I'm sure. I
Okay.
just don't understand.
Okay,
I
fine.
guess the centimeter is the cm. Yeah.
Yes, it is.
Yeah.
Okay. What's an example of a material with a low density? No, not actually water.
Gas.
Yeah, but what? Give me an example.
Air.
Yeah, but what's air? Like what?
Oxygen.
Oxygen.
Oxygen has a low density. Something lower?
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 The hydrogen.
No.
Cobalt.
Which one?
Cobalt.
Oh, no.
H2.
Yeah,
It's
no.
a hydrogen.
Yeah, no, something else.
Something else.
Yeah.
The lower.
Hydrogen, nitrogen.
Helium.
Oh, helium.
Yeah, because it's very low, 0.179. And you know it's very low. You use it in the balloons.
Yeah.
I know hydrogen is low as well, but helium is the famous example.
And for the balloon.
Yeah, exactly, yeah. You can see it's much lower,
Yeah.
0.179 kilograms per meter cubed. I think oxygen and nitrogen, like air, is about 1.3. So you know this is like 10 times smaller
Yeah.
than air. It's pretty small. So what would be a medium density? So medium is kind of something like water. Yeah. It has a density of 1,000 kilograms per meter cubed. Now you should all know that. That's a number you should know. And if you didn't know it, I think it's good to write it down. Yeah. Now, the value of the density of water is so important in science. This is actually a very important number. In fact, it's so important we have something called relative density. So, what did I say the density of gold was? It was 19,320.
Yeah.
That's about 19 times bigger than gold, roughly. 19 times bigger than water, roughly. So this gives us our next idea. Often we want to compare the density with water. So we have something called relative density. And the relative density of an object is the density divided by the density of water. So for example, here with the gold, it would be 19,320 divided by 1,000. So we say that the relative density of gold is 19.32. Now, why do you think it's important to know this? Well, one example is for buoyancy. That's when things float in the water. If S is less than 1, it will float.
Oh, yeah.
Then it floats. If S is more than 1, like gold, what will happen? It'll sink.
Yeah.
What will happen if S equals 1?
Mix up.
It just mixes together.
Yeah.
Okay. So often S is important for knowing if something will float or if it will sink. Okay. This is called relative density. I think you should write this down. And it has no units.
So the oil is
Less than one, yeah. Um, alcohol, that's the one I think. Alcohol, yeah. What is alcohol?
Chuji.
Oh,
You know what alcohol is.
alcohol is. I remember it's it's
Nitrogen.
mixed down. It's just a mix. Yeah. Like the beer.
Just like beer.
Yeah.
4.5% mix.
Chinese wine is more higher, like 60%
For wine.
degree. Yeah, but we doesn't call wine.
Oh, it's
Chinese whiskey or something.
Yeah, Chinese
Yeah.
whiskey.
Really strong.
Yeah, what's it called? Is it made from rice?
Yeah.
Yeah. What's that called?
No
What's it?
Chinese?
No, I think I know it
English?
yeah. Well, maybe it's similar. What's it called in Chinese?
White wine.
No, in Chinese.
Yeah, 白酒.
No, that's not it. Sawabi?
No, that's Japanese.
That's Japanese.
Yeah,
Yeah.
Soju is Korean one.
Yeah,
But
okay.
Chinese one is much more higher than that.
Yeah.
Okay.
They're only 17% on Korean one.
Okay. But they're all made from rice.
Yeah.
Yeah.
Oh, yes.
Buoyancy?
Boys.
Buoyancy means if it floats or sinks. This is buoyancy. There's an Irish drink made from potatoes.
Potatoes.
Yeah, like this.
Like
Like the rice wine.
Oh,
What's it called?
what's it called?
I don't think you've heard of it. Poutine. It's like 60 or 70%.
60.
Yeah. 60.
So
Yeah.
there is-
Oh.
What the hell?
It's quite dangerous.
Not really, because we drink like this.
Yeah, I know,
small
just a
bottle.
little bit, yeah.
Do you
With
know
garlic, you know.
the life water?
Yes, life water, yes.
Yeah.
I've heard of this name,
Keep
yeah.
living.
Yeah.
Wait, I tried that once in last year, and I feel bone.
It really depends on the different part of China. I mean, the people can drink quite a lot or
Yeah. Is popular drink in China?
in the restaurant.
Yeah.
Yeah, it's
Yeah,
very
it's
popular.
pretty famous in my part, actually.
In your part. Would people have it with dinner? They go to a restaurant?
Yeah, of course,
yeah.
and it's expensive. Yeah.
It's expensive.
There's a good gifts present for gives each other
Yeah.
during the festival.
Okay, you got this?
Yeah.
Okay, so here are some values which you'll need for your question. So the first one is gold. That's 19,320 or 19.32. I think you have this value. Silver, which you don't have, so you should write this down, it's 10,500. So you can see there's actually a big difference between gold and silver. You know, like gold is nearly twice as dense as silver. But maybe you know this because silver's kind of softer. You know what I mean? Yeah, compared to gold. Like gold is hard, silver's a little softer.
Yeah, it's cheaper.
And it's cheaper too, yeah. Okay, next one is nickel.
Yeah.
You know nickel?
It's kind of metal.
Yeah. 8,900. So you can see the metals are pretty dense. Next one is salt water. Salt water. Like ocean water.
Yeah.
1,030. Yeah. Next one is fresh water, which is 1,000. Yeah. Ice is 916. Now that's interesting. That's you can see that's a lot less than fresh water. It's like 10% less, 9% less. So you see here the S is less than 1. So this means the ice floats. Yeah, because it's less than 1 for the relative density.
But ice always sink in the water.
No, it floats.
No, it's the way. It's not.
It might sink in the alcohol because for the alcohol it's less. So if you put ice in alcohol, it will sink. If you put it in fresh water, it will float. Yeah. I never thought about that, but you're right. If you put it into whiskey, it'll sink in whiskey. So that means the density of whiskey must be less than 916. Yeah, that's interesting. Alcohol is only 789. Wood, like the table, is 700.
How about aluminum?
Oh, I don't know. I'd have to look it up. I'd say it should be pretty dense, though. Because all the metals, gold, silver, nickel, they're all pretty dense. Air is about 1.2. Yeah? You got all that? Okay. Alright.
So,
By the way, the wood, it's different for each tray. Yeah, of course. It's about 700. There is actually one tray, can't remember what it's called, but its density is actually more than 1,000. So if you put this wood into water, it would actually sink. I think it's some black tray in California or something like that. It's very, very dense.
In Africa.
Maybe in Africa, yeah. It's very, very dense. It would actually sink in water. But most trees are around about 700. Okay. Right, let's look at a question together. So, first thing, you have 1 litre of fresh water is mixed with 1 litre of salt water. What is 1 litre in SI units? So, a litre is not an SI unit. Remember, SI units are like metre, kilometre, centimetre, kilogram. These are SI units. Litre is not an SI unit. And we need to convert litre into SI units. So does anybody know how big a litre is in SI units? So if I said 1 metre cubed, how many litres is that?
1.
No.
It's not 1.
No.
It's
0.1.
Nope. Further away now. You don't know this? You don't know this. Okay. It's 1,000. 1,000 litres is a metre cubed. Is this new information?
Oh, no, it's not you.
Not new for you. She looks shocked. Is this new for you? Ben, did you know this or not?
Is water?
Any liquid.
1 metre cubed. How big is 1 metre cubed?
Well, about this. So it's pretty big.
1 litre, like.
1 litre is like 2 of these.
Yeah.
That's half a litre.
And we both, we buy the milk is 1 liter.
Yeah, 1 litre or 2 litres, yeah. So 1,000 litres make a metre cubed, okay? This is okay?
Yeah.
But just be clear, we don't really like to use litres in physics because this is not an SI unit. This is an SI unit. Now sometimes you use litres in some subjects like biology and chemistry.
Actually,
Huh?
we don't use L.
Well, you don't use the okay. Well, in chemistry,
Yeah.
you use litres, don't you?
Yeah.
Yeah. But it's better not to use litres. Okay, so I'll let you try this question for a minute. The first part is, what is 1 litre in SI units? So, if 1,000 litres equals 1 metre, yeah, what is it?
0.0001.
Equals 1 litre. Okay, I'll let you try this one for me now. Continue. Give it a try.
So density is since it is 1,000.
Yeah.
So, if the fresh water makes salt water, maybe I think we can't just directly add
Well,
the
which question are you doing? Which part?
the.
D. What is the combined mass?
Can we just directly to add the
Of course.
density?
You know, like, no. You have your answer for B and C.
Oh, so we just add them together.
Yeah, if I have 1 kilogram and 1 kilogram, then I have 2 kilograms.
Oh.
That's all. It doesn't matter that it's a liquid.
So the density is same like the fresh water.
For which part?
Is a F. Is
F.
that same?
No.
It's 1,000. It's 1,000.
No, no.
Density is 1,000.
Think about what I've asked you to do. I said, what is the total mass? What is the total volume?
Total mass is 2.03 kg.
Correct.
Yeah, and the
Total volume?
value is 0.002.
Correct. So what's the density?
Divide.
Yes.
1,000.
No.
It's 1,000.
It's not 1,000.
Oh. I add the 0.03.
What answer did you...
Answer to
Here, let's do this together. So what's the answer for the first one? Did you 0.001 for A?
Yeah.
B,
What?
it's 1 kilogram. C, 1.03 kilograms.
Yeah.
D,
It's,
2.03 kilograms. E, 0.002 meter cubed. And F is 1,015 kilograms per meter cubed. Did you get those answers? Yeah?
It's what's the answer? It's one
1015 kilograms per meter cubed. What?
Oh, it's 15.
15.
Sorry.
1, 5. Alright, continue. Okay, this is a question I want you all to answer for me. It's which answer is right, A, B, C. So, you have a student places 10 grams of ice into a bottle, like something like this. Okay, so they put some ice into the bottle, and the water is right up to the top, and then you put the lid on it. Okay, so there's no free space, no space. Okay, it's completely full. The bottle of water is left out, and the ice melts. When the ice fully melts, what happens to the bottle? So, first choice, the volume of the water in the bottle increases and the bottle breaks. So, your first choice is the ice melts, and then because there's no space, it expands the bottle and the bottle breaks. Okay, the second choice is no change. So the ice melts and the water volume stays the same. Or the third one, the volume of water in the bottle has decreased, so now after the ice melts, there's a little space in the top. So which do you think will happen after the ice melts? A, B, or C? You're going with C? You're thinking B? What do you think, Ben? You're thinking good. He's thinking a lot about it. You know the answer, or you think you know?
I think I know.
You think you know,
I
okay.
think I know.
So what do you think? Still happy with B?
If the ice melting,
Yeah.
the density is still like 916.
No.
Or is converts to water.
Yeah. So the answer is, Ben, what do you think?
4.
So it breaks, it stays the same, or there's some space now? It breaks, so that's A. Good, so you said A, you said B, and you said C. Oh, you changed your mind now, you're going with A, okay. So we have A, B, and A. Okay.
I think if you calculate, maybe there will be break, but it won't be happening. You just put an ice on it and it will break.
Okay, I'll tell you the answer.
Just don't
Let me calculator once.
I think if you calculate, there will be the mass will be bigger than original.
No, mass can't change. Can't change mass.
Because the density was changed.
The space changes. The question is, does the space change so that the bottle breaks, or it doesn't break?
It won't be break.
Oh, so not A.
No.
So you're back to B.
It won't be break. just
In normal life, the bottle won't be break, but if the question need the bottle. Yeah.
break. The question
Yeah.
made bottle break.
Yeah.
So there's no space. You
Yeah.
close the lid,
Yeah.
and the ice melts.
Yeah.
I think the bottle have elastic.
Okay, glass bottle.
Yeah, because the ice value is
You think C now?
the ice value is just like the 10 G.
Okay, I'll tell you.
Yeah.
And the answer is, you should have stayed with your first answer. It's C.
Yeah. But in the normal life, the ice becomes the water. How to say that? The water will.
No, it doesn't. It doesn't actually.
Why?
So, if your bottle is closed, so it's right up to the top, and the ice is in here.
Yeah.
Okay, this ice melts, right? So the density goes from 916 to 1000. So this means it's more dense. But the mass doesn't change. So for example, if this is 0.01 kilograms, it's still 0.01 kilograms.
Yeah.
Okay. Now you have density is mass over volume. So volume is density by mass. So if this doesn't change, but this
Really?
no, sorry,
Really?
no, sorry, apologies. Volume is mass over density. Thank you. This doesn't change.
Yeah.
This gets bigger, so then what happens here?
Small.
This gets smaller. So when this changes into water, it needs less space. So if it needs less space, then the water level drops. Now, Summer, if there was no lid on the top, okay, and if it was like this, and the ice was floating, so some of it's in the water and some of it's not,
Yeah.
and the ice melts, what do we think? Will the water level drop? Will it go over? Or will it stay the same?
Yeah, it's go over.
No.
It's but I remember when I put some ice into the color, and the color,
We can try.
yeah.
You can try.
But I remember that the color will.
Maybe you spilt it.
No.
No, I promise you.
Yeah.
If you did this at home, if you put some ice into a glass of water,
What's
and
the
put it-
role
put-
of the what?
put it on the table, the water doesn't spill over.
But I just think, yeah, if I put some ice into the color, and there will be some liquid out of the bottle.
No, there shouldn't be. There shouldn't be. Now, what sometimes can happen with water, there's this special effect in water where the water can rise up the edge.
Yeah.
You know this if you have a tube and you have water inside of it, it
Yeah.
bends a little bit. So it's possible that some of the water leaks out because it bends. It's not because the ice melts. You know, what you could do is, you could do a little simple experiment at home. You could have a cup with some water and some ice in the top. And then you can put it into a bowl. Okay?
Yeah.
There should be no water in this.
Yeah.
It should be still dry. Okay?
Or then maybe
You test it.
maybe no, I won't test.
Okay,
Because
don't.
I think my thought is wrong. Yeah.
So is when the bottle is full of water, put ice in, or after put ice in is full?
Yeah, so in my example, it was nearly full, and then I put some ice in. I pushed some ice into it and closed it so it's full.
So if they don't close it,
If you don't close it, it stays the same because some of the ice is sticking out.
so if I don't close it, the bottle is here. When the water is
Yeah, it'll
totally
stay.
full,
Yeah, if you don't close it and it's full and the ice is sticking out the top because it's floating, then the water will not change its, it will not spill out. It will stay at the top.
Yeah.
Yeah,
All right.
it's okay?
Yeah, it's okay.
That's interesting, I think. Okay. Right. Here is one I want you to try. Some silver jewellery is a mixture of silver and nickel. So if you have jewellery, sometimes it's not silver, it's just a mix of silver and nickel. Yeah?
Yeah.
To make it cheaper. So for example, maybe you have 10 grams of nickel and 1 gram of silver, and you mix the two together. Do you understand? My question is, what is the density when you mix 10 grams of nickel with 1 gram of silver? See if you can work this out. What's wrong?
Power.
Oh, that means 10 power minus 8. You got an answer, Ben? No?
No.
No.
So that's.
That doesn't look like the right answer. Too small. 10 to the minus 6. No.
Give up.
Give up? Okay. Shall we calculate? No, somewhere's going to get it.
It's just a G with the CM cubed. G with the CM cubed.
Yeah.
And
That's close to what Ben said. We can calculate.
902.
That's not,
Three.
yeah. Let's calculate. Let's see.
Yeah.
Let's see. Okay. So, density is mass over volume. So it's the mass of the nickel plus the mass of the silver over the volume of the nickel plus the volume of the silver.
Yeah.
Yeah? Okay, what did we say? That's 11 grams, isn't it?
Yeah.
Okay.
And,
But you have density is mass over volume, so volume is mass over density.
Yeah.
So you can change this into mass of the nickel over density of the nickel plus mass of the silver over density of silver. So that's 0.011 over 0.010 over, what is it for nickel?
8900.
Yeah? Zero.
No, just two.
0.001 over
105.
105.
Oh.
Oh. Okay. So if you calculate that, what do you get?
I can't calculate.
I'll left calculator.
The first one is
No, final answer. What you get? Ben, what do you get?
Wrong.
Wrong. Can you hand me the calculator?
I get wrong.
Yeah, but what's this? Can you calculate this?
my slow ways is I'm first to calculate the
volume. Yeah,
Yeah,
that's fine. That's fine.
And
You should get the same answer.
The volume of the nickel is 0.095.
Sounds kind of big.
9025.
Thank you. What answer did you get? This is close to what you got, wasn't it?
9024.
Okay, that's fine. Yeah, that's fine. Okay. Is this okay, Gal? Yeah?
Yeah.
Is okay? Is okay?
Yeah,
It's okay. Yeah, and Ben is okay?
Yeah.
Yeah? This was an exam question, like a section A question. It's not too difficult once you get the idea. Yeah. Okay, so that's kind of the hardest example. Let's see what you've got to do. I don't think this is too difficult, right? Let's see. If you can try these now for a few minutes, okay?
Where is happy?
He emailed me. He said he doesn't feel well. He has to go home.
Oh.
It's the opposite to Summer, who didn't feel well this morning but came in now, right?
Yeah,
You
he
know
just
that?
came
Yeah,
for business.
yeah, I know everything. I know everything.
Because
I know you were sick and now you're here, and Khalifa is now sick, so he's not here. You know.
yeah, but
I know that Colum,
yeah,
your tutor,
yeah.
doesn't like Ben.
What?
Why?
I just joke.
Based on their
Joke. Joke.
Okay.
What's
But why?
No, it's just a joke. It's just a
I know
joke.
the reason for why. Okay, I'm talking.
The reason is.
never absence.
No, the reason is I was just talking to Colin today about this class. So I was saying I have some concerns about English. Saying some students maybe their English is a little bit of a problem. You know.
But the physics is not a problem. Yeah.
I don't know, because your test, you know.
But methods. I will look. I will look.
Do you know what is the Khalifa get?
I think someone told me Khalifa only got one right.
Yeah, I think he said that in class. Yeah.
So where is the
I think he was just joking.
Yeah.
So he started late, you know.
early version?
But
Yeah.
he's very smart.
Yeah, I think he is very smart.
I'll have to talk to him.
So-
I don't know what happened.
So the English is not.
It's not. Slave got B, you know, and no one got A, so. See?
I wouldn't say the English is not important. I would say it's not as important. True. If I had a choice between good physics and good English, good physics is better than good English. But what is best is good physics and good English. This is best. True? True. True. Okay. All right, try these for a few minutes and then we'll do the next lesson, which is also pretty easy.
What?
No, English. Practice English, okay?